For the above quartic polynomial, f of x equals negative x to the fourth over 2 minus 0.5x cubed plus 15x squared, identify the interval on which f is concave up. Okay, so to determine where a function is concave up, effectively we're looking for where it looks like an upward-facing parabola. Okay, now, so if I look to where this thing looks like an upward-facing parabola, initially I might look at, say, this region right through here, okay? Because that looks like a parabola opening upward to me. Now, the thing you'd have to be careful about is I've actually copied over some of the region where it looks like a downward-facing parabola, because, to me, like this part right here certainly looks like a downward-facing parabola, but so doesn't that. And over here, this looks like a downward-facing parabola, but this looks like part of it. So the thing is, inflection points, they're a little tougher to discern than minimums and maximums. But looking at this, it looks to me like the inflection point's right about there, where it changes concavity, and then here, maybe about right there. So concave down on this interval, so downward-facing parabola, then upward-facing parabola, then downward. Which means my inflection points are probably at negative 2.5 and positive 2, but that's not necessarily a very precise way of coming up with it, just eyeballing these things. So let's rely on the analytics. Well, we do know that inflection points, these occur whenever the second derivative is equal to 0. So let's take a look at the second derivative here. First, I have to get my first derivative, which would be, so 4 times negative 1/2 would be negative 2x to the third, then minus 1.5x squared, plus, oops, that was going to be 30 times x, just using the power rule. The second derivative then is going to be negative 6x squared minus 3x plus 30. And in order to find out where that second derivative has zeros, because I'm looking for these inflection points, I need to set the second derivative to 0 and solve. To make things easier, it does appear that there's a common factor of negative 3 here I can pull out, which would leave me 2x squared plus x minus 10. All right, now I'm going to try and factor the resulting polynomial. So 2x and x multiply to x squared. 5 and 2 would multiply to 10. This would be 5x, and that would be 4x, so I would need this to be positive and that to be negative in order to get the middle term to work out. So 5 times negative 2 is negative 10. Great. Okay, so that means if I take each of these factors and set it equal to 0, then that's going to reveal the location of these inflection points. And so this is, of course, 2x equals negative 5, or x equals negative 5 halves, which is negative 2.5, like we said, and x equals positive 2. So those are, in fact, where the inflection points are, but if it's difficult for you to eyeball those, then you want to rely on the analytics to get them instead.